Today we're going to discuss how to create Lewis dot structures and show the electron configuration of each atom. We could use the Bohr model to help us with both of these. The Lewis dot structure is simply the element symbol surrounded by a number of dots representing valence electrons, which means the outer shell electrons. Electron configuration just shows the number of electrons on each energy level with a dash in between them. Okay, let's go back and look at the Bohr models for each element that we constructed and use those to create Lewis dot structures and write down our electron configuration. A Lewis dot structure for a hydrogen atom would simply be the hydrogen symbol H with one electron dot next to it. That dot representing the one electron in the outermost shell, the valence electron. Its electron configuration would simply be a 1 with a dash, indicating that the K shell has one electron in it. The Lewis dot structure for helium would simply be a helium symbol with two electrons written around it in an order. The electron configuration would simply go 2 dash, indicating that there are two electrons in the K shell. Some people ask how you order the electrons around a symbol. If we have our symbol SY, and that's a made-up symbol, I break up the area around the symbol into 4 quadrants. And based on the number of electrons, I fill them up in an order. If an element has 1 electron, I put it in the first box to the right. The second electron I put in the top box. The third electron I put in the box to the left. The fourth one in the bottom box. The fifth one, the sixth one, the seventh, and the eighth. Let's do Lewis dot structures and electron configurations for the elements in the second period. When doing a Lewis dot structure, remember we only show the valence level electrons. So lithium has the same Lewis dot structure as hydrogen because they only have one electron in the outermost shell. But its electron configuration is different because you have 2 electrons in the K shell, so it goes 2, and then you have 1 electron in the L shell, 1. So it goes like this, KL. Beryllium has 2 valence electrons, so it's going to have a Lewis dot structure that looks like this. And an electron configuration of 2-2 because it has 2 electrons in the K shell and 2 in the L shell. As we go from left to right across the periodic table, we add more and more electrons. As the atomic number increases as we go from left to right across the periodic table, we also add electrons. So a fluorine atom has 7 valence electrons. You can count them up here. 1, 2, 3, 4, 5, 6, 7. So it's going to have 7 dots around the fluorine atom. So you go 1, 2, 3, 4, 5, 6, 7. And it's going to have an electron configuration of 2, because it has a full K shell, dash 7, because it has 7 valence electrons in its L shell. Neon has 8 valence electrons, so it has a full outermost shell. So you'll notice that the Lewis dot structure for neon has 8 valence electrons, or 8 dots around it, and an electron configuration of 2-8, because it has 2 electrons in the K shell and 8 in the L shell. Okay, in the third period, we see that we have sodium, magnesium in groups 1 and 2, and chlorine and argon on the far right, group 17 and 18. You should notice that because we're in the third period, we have 1, 2, 3 energy levels. So we have a K level, an L level, and the M level. The Lewis dot structure only deals with valence electrons, so the sodium atom has 1 outer shell electron, so that's the Lewis dot structure for that. Its electron configuration, though, has 2 electrons on the K shell, 8 on the full L shell, and 1 on the M shell. Magnesium has 2 valence electrons, so that's its Lewis dot structure, and it has 2 electrons on the K shell, 8 on the L shell, and 2 on the M shell. The elements with the atomic numbers 13, 14, 15, and 16 just keep adding electrons to the outer shell. So that brings us to chlorine, which has an atomic number of 17, and it has 7 outer shell electrons. So we draw them in. We go 1, 2, 3, 4, 5, 6, 7. The Lewis dot structure of chlorine has 7 dots indicating the 7 valence electrons around the outside of the chlorine atom. And its electron configuration has 2 electrons in the K shell, 8 on the L shell, and 7 valence electrons on the M shell. Argon has 8 electrons in the outermost shell, so it has 8 valence electrons. And an electron configuration of 2, 8, 8, representing the K, the L, and the M energy levels. Let's look at the last 2 atoms that we're going to be looking at this year, potassium and calcium. Potassium and calcium are both in the 4th period, so they have 4 energy levels: the K shell, the L shell, the M shell, and the N shell. So you have 2 electrons in the K shell, 8 on the L shell, 8 on the M shell, and on the outermost energy level, or shell, for potassium, you have 1 valence electron. So it has a Lewis dot structure that looks like this. Calcium is also going to be similar underneath because it has 4 shells. They all have to be full before you can fill an outer shell. So it has 2 on the K shell, 8 on the L shell, 8 on the M shell, but it has 2 valence electrons. So its Lewis dot structure is going to look like that. Hopefully you're understanding and you get the point by now. And you can see that there's a pattern in this. If you have any questions, please feel free to ask.